So today we're going to start talking about geometry. We're going to be learning a lot of vocabulary words. I hope most of these are not new for you. There will be a few that should be new, but most of these you should already know. So if you don't, you got a lot of studying to do. And we are learning some fairly, not very technical definitions. So when you get to high school geometry, you might have a few more definitions that they talk about. Alright, so let's start with a line. A line has no endpoint, so you need to think of a line as going on forever. We will label a line using 2 points, but it's made up of many points, and it's very important. So like if we have this right here, and we have an A, B, and a C, I'm going to go ahead and add this for later. We have line A, B, and you need to put the symbol, arrows on each end, when you name a line. So take 2 points. Don't name it line A, B, C. Just use 2 points to name that line. A ray has 1 endpoint. Thought I was going to be able to use the same drawing for everyone, but I guess I will not be able to. So we have a ray. It can be labeled on here. It can be on a line, and we can have 2 points. But we label a ray with the symbol, an arrow on one end. So even though AB was a line with that other symbol above it, it is also a ray with this symbol above it. So it's going to be important that you write those symbols, and also when you read it, you read this line ray AB. Next we have a segment which has 2 endpoints. And again, we can have segment AB So segment AB, you write the letters AB and you put the little segment notation above it. So AB can be anything depending upon what the signs are above it, or not anything, but those sorts of things. You can also have segment BC here and segment AC, so you have a lot of different segments there. Forgot to mention this. Before, when we were doing lines, line AB would be the same as line BA because it passes through A and passes through B and keeps on going. So those are the same. Is segment AB the same as segment BA? Yes. Is ray AB the same as ray BA? No, those would be different because ray AB starts at A and goes this direction. Ray BA starts at B and goes this direction. So they are different rays. An angle is 2 rays with a common endpoint, and that common endpoint is called the vertex point. So if we have this, and again, you need to remember I'm just labeling certain points here. There are many other points on these lines, or an infinite number of points. So when you do name an angle, you name it with the symbol, a picture of an angle, and the vertex point goes in the middle, so I could name this angle DBC. This is angle DBC. So it doesn't matter how long the rays are. It's really what part of a circle. That's what this is representing. What part of a circle is this? And that's what an angle is. So it's always measured in degrees, B being the vertex point here. Okay, and we'll talk about how to classify angles in a little bit. Next we have congruent, which means the same size and shape. And hopefully you've already heard that. The symbol for congruent they'll be using is a equals with a little wiggle mark above it. You read that congruent. So make sure if you see that, you know how to read it. Acute angle measures less than 90 degrees. Oops, sorry, I didn't have my degree marked on there. So degrees. A right angle measures 90 degrees. An obtuse angle measures between 90 and 180 degrees. So those are 3 words. I hope that you already did know those. Complementary angles that add up to 90 degrees, and we will be using that in some of our homework later. So if you have an angle like this, a little square means it's a right angle, and I tell you this is 20 degrees, you should be able to figure out this angle because you know it adds up to 90. So 90 minus 20 is 70 degrees. So that's important to know. And then we have supplementary angles. They add up to 180 degrees. And what does a straight line measure? A straight line measures 180 degrees. That means from here to here is 180. So if you know this much is 40, this angle here would be supplementary to it, and it would have to be 140 degrees because they have to add up. So that's an important thing to know, that a straight line measures 180 degrees, and that's where supplementary angles come in. Vertical angles are congruent, and again we just learned congruent, same size and shape. So vertical angles you get when you have two lines that cross, and this angle 1 and angle 2 would be considered to be vertical angles, and they are the same measurement. This angle 3 and this angle 4 are vertical angles. So it's not really a definition of vertical angles, just a property about them that they are congruent. Parallel lines are lines that never intersect. I hope you all knew that. The symbol we use for parallel lines is just up and down lines. So it kind of looks like an 11, but you do read it parallel. So they will never intersect. They're the same distance apart. Next we have perpendicular lines, and perpendicular lines, when they cross, they form 4 right angles. So these two lines would be an example, and you see the 4 right angles that they create. The symbol for perpendicular is an upside down T. Polygon is a simple closed figure whose sides are segments. So lots of words there, so let's talk about that. Simple means that they do not cross. Closed means it does come together, and the sides are segments. So would that be a polygon? No, because this side is not a segment. Would this be a polygon? No, because it's not simple, because the lines cross. Would that be a polygon? Yes. So it's closed, its sides are segments, and they don't cross like that. So that's what a polygon is. Then we have different types of polygons, and one type is a triangle, and we're being specific here with different types of triangles, which we'll talk a little bit more about these later on. But in an equilateral triangle is a triangle with all sides congruent. So all the sides are congruent. Equa meaning equal, and lateral is the word for side. So it kind of defines itself in the meaning there. And also all angles would be congruent too. Next we have isosceles triangle, and in an isosceles triangle at least 2 of the sides are congruent. Then we have a scalene triangle where no sides are congruent, and we will talk a little bit more about these in detail later. This is just a quick overview. A quadrilateral is a 4-sided figure. I hope we know that. Hopefully we know what quad, the prefix, means. So any 4-sided figure. Now, we have different types of those, and we will talk later on about those. Continuing to classify then, we have a trapezoid, which is a quadrilateral with 1 pair of parallel sides. So one pair of sides are parallel, the other sides are not. So that is an example of a trapezoid, if I close it there. And we will talk more about those in later time, like the next couple of days. Then we have a parallelogram, which is a quadrilateral with opposite sides that are parallel. We have a rectangle, which most of you know is a quadrilateral with opposite sides parallel, and they actually happen to be congruent, and it has 4 right angles. So that's in addition to that. Then we have a rhombus, which is a quadrilateral with opposite sides parallel, and all sides are congruent. And then the most special quadrilateral is a square. It's a quadrilateral with opposite sides parallel, 4 right angles, and all sides congruent. Pentagon is a 5-sided figure. Hexagon is a 6-sided figure. Septagon, also called a heptagon sometimes, is a 7-sided figure. Octagon is an 8-sided figure. Decagon is a 10-sided figure. I did leave 9 out. That's a nonagon. And the angles in a triangle always add up to 180 degrees. We're going to use that later on, but that's an important fact to know. Angles in a triangle add up to 180 degrees. The angles in a quadrilateral add up to 360 degrees. 4 90-degree angles, like in a square or a rectangle, should make that easy to remember. Now these are the definitions that might be a little different for you. A central angle is formed by joining 2 points on the circle to the center of the circle. So if we have a circle, we have the center. It's formed by joining 2 points on the circle. So this would be an example of a central angle. The altitude of a triangle is a perpendicular segment from one vertex of a triangle to the opposite side. A lot of times I use the word height for altitude instead, but so if we have a triangle, perpendicular, remember, means it's going to make a right angle from one side to the side opposite, or one vertex to the side opposite. So that would be an example of an altitude. We can have an altitude of each one. I'm not sure if that makes a right angle. Pretend it does. We could have one coming in here that makes a right angle. So you can have altitudes from every side. A bisector is something that divides something into two equal parts, and we'll be doing that a little bit with constructions. And then a diagonal, I hope we know, and we used that already once, connects two non-adjacent. Adjacent means next to, so they can't be next to each other. So that would be like a diagonal right there of this rectangle. You also have one going the other direction. So it connects two sides that aren't next to each other.